Welcome everyone. We're going to work on section 5.5 today, which answers the age-old question, or the one that Kara asks every couple days, is why in the world are we learning this? Okay, we are going to be working on linear modeling and how it affects real-world problems. Now, before we start, every one of these wants you to create an equation and solve from an equation. But truth be told, if you're in a real-world situation, you're not going to do that. You're going to use the critical thinking and problem-solving skills that you're learning in these chapters in order to solve these problems. So when they say create a linear model, I care most about, can you solve the problem? So let's look at an example. From 1985 to 1997, the number of movie theaters in the United States increased by 750 per year. In 1993, there were 26,000 theaters. Create a linear model or an equation. Now, when we work on these problems, there are two things that I need you to figure out. I need you to figure out the starting point and what I want you to think of as where the time starts, or x equals 0. Where are we beginning? And the second thing you need to figure out is your m, or we learn that as slope, but you can also think of it as rate. Something per. Okay? First thing we got to figure out is, where does our time start? Well, the first problem says from 1985 through 1997, our starting time is 1985 is our x equals 0, because that's where the problem begins. And our slope, our rate, always is going to involve the word per, like per mile, per gallon, per cup, okay, or per year. Meaning our slope is 750. Now, we want to create an equation. We have two equations that we know, y equals mx plus b, and point slope, the y minus y1 equals m parentheses x minus x1. Those two we've been working on. Well, the only other information we have in this problem is right here. In 1993, there were 26,000 theaters. Well, we know that 1993, if 1985 is our starting point, 1993 is going to be x equals 8, and our y value, or the number of theaters at that time, is 26,000, meaning we have an ordered pair and we have a slope, meaning we can use this equation. So we have y minus 26,000 equals 750 parentheses x minus 8. And if we wanted to, we could turn that into y equals mx plus b. But this is what we're doing here. We're creating an equation. Now, if you have your notes out and you want to star something from this slide, the two things that you need in order to start a problem are the starting point and the rate. Okay? So I'm going to do one more here, and then I'm going to start giving you the reins to go ahead. So once again, we need that starting point, and we need our rate. So let's look through our problem. From 1985 through 1997. Oh, there's our starting point again. So x equals 0 is 1985. And our rate in movie attendance in the U.S. increased by 25 million per year. Okay, so that means it's 25 million. I'm going to put million as the label per year. So in 1994, movie attendance was 13,000 million, which is a weird sounding number. So that means our equation will be, or our order pair will be 9, because it's 9 years past our x equals 0, and our y value will be 1,300 million. Okay, I would like you to try to create your own equation from this information. Okay, hopefully your equation turned out to be y minus our y1, which is 25, because it's million. Oh wait, literally, stop. That's not right. Y minus 1,300, sorry, I was looking at the wrong part, right there, because that's our y value, is equal to our 25, because that's this, parentheses x minus 9. Now, if you actually wrote out these numbers, that's fine. Okay, but I just left the million as the label, just to shorten them up. So there's our equation. Okay? So here's a model that we're given, or an equation, and it says if 1985 is n equals 0, What is the number of theaters in 2005? Well, number of theaters is our y value, and we need to figure out if this is n equals 0, 2005 is n equals what? Well, 1985 is our starting point. This is 20 years in the future, so our n equals 20, and all it's asking us to do is plug it into our equation. So we get y equals 750 times 20 plus 20,000. Okay, so 750 times 20 is going to be 75 times 2, which is 150 with a couple extra zeros attached to it. We add those together, and so our y is 35,000. Of course, if you want to use a calculator, it's fine. Our label is theaters. Okay, so that's an example there. I would like you to try this one on your own. See how we're doing on time. Running a little long, but nothing too horrible yet. Okay, so our n is 23 years past our n equals 0. And so we plug it into the equation. 750 times 23 plus 20,000. That is calculator time. So 750 times, oops, I don't remember how to do the times button. Sure, there's a shortcut somewhere. Times 23, whoa, plus 20,000 is 37,250 theaters. One more example. Alrighty, here's an example of a real-world problem. So you're having a barbecue, and you need to buy a certain number of pounds of hamburger and a certain number of pounds of chicken. Okay, but you only have $60 total that you can spend on this barbecue. So you have many options on how to solve this problem. Okay, but the idea is if you spend, you have hamburger here. Let's say you have chicken. You can spend a certain amount of money, but it needs to equal 60 total. So if you spent $30 on hamburger and $30 on chicken, you would add up to 60. So that would work. But if you spent, $30 on hamburger and $40 on chicken, that does not work. So that's not an option. So if we just think about this logically, let's say I'm going to spend 4 pounds of hamburger. Okay, so 4 pounds gives me 12 total dollars because it's $3 per pound. Meaning I have $48 left that I can spend on chicken. So I have to spend $48, so that's going to be 12 pounds of chicken. So that's one way that we could solve it. 4 pounds of hamburger and 12 pounds of chicken. That would give me an answer. Now I want you to try to see if you can find your own answers to this. And then I'm going to show you a nice little shortcut. Okay, some of the other possibilities here could be 8 pounds. Well, circle this here. You could do 8 pounds of hamburger, and that would give you $24. And so then you could do $36, so 9 pounds of chicken. Okay, so there's lots of other examples that you could do. You could do 12 pounds of hamburger and then 6 pounds of chicken. Okay, tons of different answers. Now, a nice little shortcut here is since this is per pound and this is per pound, you could do 3 times the number of pounds of hamburger, which you're trying to find, plus 4 pounds or $4 per pound times the number of pounds of chicken is going to be equal to your 60. And now you're just trying to find ordered pairs that make this a true statement. Like 412 makes this a true statement, or 8-9 makes this a true statement, or 12-6 makes this a true statement. And you can solve those just like we've been solving other things. So this is a nice little equation method. Because these are per, you can just do 3 times the number plus 4 times the number gives you a total. Or you can do a table method. Either way is fine. So I'd like you to try this one on your own and see how you do. Okay, this is a nice tricky problem. Okay, and this is about as difficult as I will possibly get. But through a little bit of trial and error, your answer should be that 10 pounds of potato salad and 5 pounds of pasta. There might be other answers out there as long as they match up. But obviously here, you don't want to be buying, 2.5 pounds, although that would be possible, but it does make it more complicated. Here's the equation that I found. And this just goes to show you how complicated real-world problems can get rather quickly. So this will take some time, okay, but I think it's a good opportunity for us to actually start working with some real-world problems. Here's what we're going to be doing, okay, and if this takes you a couple days, that is totally fine. Have a good night.